So this is the information you should have filled out already on your lab handout. The reaction, iron reacts with copper 2 sulfate pentahydrate to yield iron 2 sulfate, copper, and water. Then the data table, everything should be filled in except for the mass of copper recovered. Be sure to note the observations of iron and copper 2 sulfate pentahydrate before and after the reaction. In order to get the mass of copper recovered, I need to take the mass of the beaker and copper recovered, subtract it from the reaction beaker to simply get the mass of copper by itself. So I'm going to record that down here in my data table, 1.08. So now let's go and solve these problems. So question number 1, determine the limiting reactant and excess reactant. So we have a mathematical way that we learned this past Friday in order to determine which reactant is the limiting and which reactant is the excess. So I'm going to use my lab observations to predict my limiting and excess reactant. So I have my lab data over here. So this right here is the copper that was recovered. And then this is the solution. So the iron 2 sulfate solution. So we remember the copper 2 sulfate pentahydrate, our starting reactant, will have the same blue color. Okay, it is slightly less blue in this product, but we can still see a hint of that blue. So based on that observation alone, y'all, I'm gonna write out iron and copper 2 pentahydrate. I'm going to list this as my excess because I still see some of it in my product, whereas I don't see any more iron. So I'm going to call that my limiting reactant. And now I'm going to solve the following problems in order to mathematically determine and analyze which one is truly my limiting and excess. And as you guys can see, spoiler alert, we are right with this prediction, but let's solve it mathematically. So number 2, it says, calculate the number of moles of iron consumed based on the actual number of grams used. So our starting number for grams, if you guys don't remember, is 1 gram here. So that's what I'm going to start with. 1 gram of iron. Okay. So, converting it to moles, to cancel out the unit I don't want, I put it on bottom. The unit I do want goes on top. Plug in numbers. And I get 0.0179 moles of Fe, or iron. So, since I got moles, moles is very easy to work with, so I'm going to always start with this mole number here. So I'm going to underline this for all the problems, okay? So number 3, it says calculate the number of grams of copper 2 sulfate pentahydrate based on the actual number of grams of iron used. I converted that grams into moles. So I'm going to start off with moles to save me a step. And now I'm going to convert to grams of copper 2 sulfate pentahydrate. And so I'm going to use my mole chart to help me out. Mole A and then mole B. So I'm in moles. Next step is to get to moles of my substance. So I'm going to put down moles of Fe on bottom to cancel out real quick. and then moles of the substance I want. Copper 2 sulfate pentahydrate. And then the next one is to go to grams. So grams of the substance I want. Copy and paste to cancel out. Now plug in numbers. So whenever I have moles over moles, y'all, I take a look at my balanced chemical equation, and it is all 1. Then I have, I see that I filled in the moles here already. So 1. And then grams, I need to use my periodic table and calculate the molar mass of copper 2 sulfate pentahydrate. So I'm going to use the space up here to work. So Cu 63, I only have 1 of it. Sulfur 32.07. Oxygen, but I have 4 of it. So 16 times 4, 64. Add them up and get 59.62 grams per mole. But I need to add my water now. So I'm going to take this mass, 159.62, plus 5 times the mass of water. So the mass of water is 18.02. And my final mass would be 249.72 grams per mole. So I'm going to take that number and plug it in here. So now I'm going to multiply, and I get 4.47 grams of copper 2 sulfate pentahydrate that has been consumed, that was used up when it reacts with 1 gram of iron. So now, in order to determine which one is limiting and which one is excess, I have to analyze this value. So the question I have to ask is, do I have enough copper 2 sulfate pentahydrate to react with that 1 gram of iron? So do I have enough? What we started with was 6 grams, and it only consumed 4.47 grams. So the answer is yes, I have enough. So this copper 2 sulfate pentahydrate is my excess reactant. And if I know my excess, I automatically know my limiting, which is the other reactant. So this has been confirmed through questions 2 and 3. Okay, so it says calculate the amount of excess reactant remaining. So I started off with 6 grams. This is, again, started off. I'm going to subtract it from the amount that was used in the reaction. And then I have what remains. 1.53 grams of copper 2 sulfate pentahydrate that remains. I like to think of it as the leftover. And we do see it from the picture before. I'm showing y'all again. I still see some of that remaining there. It's not all the way green. I still see some. Okay. So number 5, it says calculate the mass of copper that could be produced based on the number of grams of iron used. So I'm going to convert to grams of copper, starting off with grams of iron, but again, I already converted that grams to moles. So I'm going to actually start off with moles. 0.0179 moles of iron. I don't want moles of iron, I want copper. The next step, I need grams. So moles of copper cancels out, copy and paste on bottom, and then grams of copper on top. Plugging in the numbers, so the coefficients are again 1. Anytime you see moles under or over something that's different, is always going to be 1. And then that grams, periodic table, that G tells me to go to the periodic table, 63.55. I'm multiplying, and I get 1.14 grams of copper. So this right here is my theoretical yield. And if I have theoretical, I can calculate percent yield, because actual is just the data. So the actual copper produced in grams from the lab was 1.08 grams. I'm going to plug it into my equation here. 1.08 grams divided by my theoretical I just calculated. And I get 94.74%. Is your percent yield optimal, or is it low based on theoretical yield? So our percent yield is optimal because the yield is higher than 90%. Okay, last question. Is the conclusion. So you guys are going to be writing this conclusion yourself, okay? It says, be sure to include percent yield of product obtained and discuss if this yield is considered optimal. If it is, provide procedures that went well with your copper recovery. And if that percent yield is low, discuss factors that influence the low copper recovery. So you guys can also discuss why it wasn't 100%. Was there something that we did that could cause the percentage to be lower than 100%? Okay, and that's it for today. After you guys are done with this, be sure to take pictures with the cam scanner or notes app, and then convert it into a PDF to submit on Canvas. Okay, y'all, have a good one.